Okay, this is when I plug it in, I'm going to get cos 0 is 1 minus 1 over 1 minus 1 is 0 over 0. Okay, so there's my condition. So I'm going to apply L'Hopital's. Okay, so I end up with the limit as x goes to positive infinity of negative sine 1 over x, chain rule times negative 1 over x squared. So same thing here, becomes sine 2 over x times negative 2 over x squared. Okay, x squareds cancel, those cancel, those cancel. So simplifying the expression, I get that. I get sine of 1 over x over 2 sine 2 over x. Okay, plugging that in, I get 0. Sine 0 is 0. Infinity in there becomes sine 0 again. So I get 0 over 0. So it gives me the indeterminate form. That means I apply L'Hopital's one more time. In applying L'Hopital's, I end up with cosine 1 over x, chain rule times negative 1 over x squared, cosine 2 over x, chain rule times 1 over 2 over x squared, negative 2 over x squared, the negatives canceled, x squareds cancel, so I end up with limit as x goes to positive infinity of cosine 1 over x for cosine 2 over x. As x goes to infinity, cosine of 0 is 1. Cosine of 0 is 1 in the denominator as well. There is my limit. For the last one here, it looks like this, number 6. I'm going to do it over here. Limit as x goes to 0 of square root 1 minus x, square root 1 minus x squared over x squared. Okay, I plug in my 0, I end up with 1 minus 1 over 0, so 0 over 0. There's my condition. Okay, just separate this up, work out. Okay, there's my condition. Apply L'Hopital's. Okay, applying L'Hopital's, I end up with limit as x goes to 0. This is 1 over 2 square root 1 minus x times negative 1. The chain rule for that, minus 1 over 2 square root 1 minus x squared times negative 2x. Okay, for chain rule for 1 minus x squared, all over, that would be, I think that was just x. Let me just double check that. Yeah, that was just over x, so still the derivative of x is 1. Okay, so that was a mistake here. When I simplify this, actually I don't really need to simplify this, do I? I can just plug in and evaluate. Okay, so this is equal to negative 1/2 minus, that's going to be 0. So evaluating my limits equal to negative 1/2.